It's not really about learning how to use a computer or how to learn a particular piece of software. You learn that along the way, but that's not the point of computer science. It's really about solving problems and applying these techniques that you learn to solve new problems that might have nothing to do with computer science on the surface. You are certainly exploring new techniques, and you're applying your new techniques to new situations. So you're constantly trying to discover new properties and new algorithms and new methodologies to attack a problem, to solve a problem, and to look at the properties of a problem. In that sense, I feel like it's a science that your purpose is discovery. There's also experimentation that goes on in computer science. A lot of times people are focusing their attentions on constructing models.
N non-terminal nodes, and there are n+2 on the path.
You can get some immediate feedback as to whether or not you've done something right. You write a program, you run it, does it actually output what it's supposed to? And if it doesn't, you go back and you tinker with it and you play around. Sometimes you scrap it and start all over again. There's a really nice problem-solving aspect to it that's very applied and very, you can see the results right away. So that really appealed to me. And although I end up doing the math side of computer science, the problems that I study in the math side are very applied.
Let's see. I can replace this larger parse tree under this T.
I do really like teaching at Oberlin. The students here are very engaged. There is a big difference in the kinds of students that I see. The students here, they sit up in their seats and they're very excited and they ask a lot of questions. They really pay attention. They don't let anything slip by. Sometimes you maybe wish that they would let something slip by, but they definitely want to make sure that they are understanding what is going on for the sake of learning. Here I teach the introductory computer science courses, the first 2 courses in the sequence, and then I teach a more advanced theory course on computational issues, on what problems you can and cannot compute with a computer. What problems are out there that just cannot ever possibly be solved by a computer, period. For example, a lot of scheduling problems just aren't feasible to do in a reasonable amount of time, and by feasible I mean you can't get the best solution, the optimal solution. And scheduling problems, they come up all the time in airline scheduling, trying to get planes, when should they take off, when should they land, who should fly the plane, given all of the restrictions that you have. And even a small difference in the quality of your solution might make a large difference in their profits, for example. Which would somehow guarantee that no matter what your brother did, you'd be happy with either one. So you would have to. The best reason to study computer science is that you learn how to solve problems in a very logical way. You learn how, given a problem that might be a problem from biology or physics or economics, you take this problem and you really try to find what is the underlying mathematical question that's being asked. So that's the first step, which I think is a skill that a lot of people don't have. So you learn to ask yourself, what is the actual fundamental problem, and then how do I break that problem into smaller sub-problems that I can actually manage to solve, and then put those things back together again. And it's a way of thinking, and it's techniques that are applicable in a lot of different areas, not just computer science. And it gives you a very good foundation for going out in the world and solving problems anywhere. It sounds very vague, but it really is true. I think that you can use the skills that you learn in your computer science courses in everything that you do.